So mass is not zero in space. Now this is, by the way, this won me PowerPoint of the year in 1997. Okay, watch how weight is animated. Watch. See, it comes down. Yeah. I know. That makes you all worth it, right? You're learning a little better now, I think. Right? So weight is the force of gravity acting on an object. Weight is therefore, if its force, going to be in what units? Pounds or? Not grams, not grams. Newtons. It's going to be in newtons is what we're going to use, right? Okay. And then a dyne is, there's a unit of, our unit of measure is meters, kilograms, seconds. Dynes are centimeters, grams, seconds. Okay. So that's the CGS unit is dynes. Okay. If you're dying to know what it is, some laughter there, right? I think it's 100,000. Yeah, it would be because it would be 100 times because it's centimeters, or there's 100,000 dynes to a Newton because there's 100 centimeters to a meter and there's 1,000 grams to a kilogram. Yeah.
Does blood ever rush to your head if you're in space?
Blood ever rush to your head if you're in space? Yeah, if somebody accelerates you. Yeah. Yeah. Or if you see that person you've got a crush on, you know. It's like. And then pounds is also as a unit of force. So when they talk about pounds, like you get the little Estes rockets, they talk about the thrust in pounds, right? So weight is zero in the absence of a gravitational field. If you're not near a massive object, if you're not near the Earth or a black hole or something like that, right? Then you can be weightless. So if you go into space, you will be weightless, but you will not be massless. You'll still be there. There just won't be a force of gravity on you. Yeah? And then to solve for weight, the formula for weight is just simply this, if you haven't already figured it out, is that weight equals m times g, right? G is, on Earth, 9.8 newtons per kilogram. Now, and why am I writing it instead of meters per second squared? Why am I writing newtons per kilogram? A, because I can, they're the same thing, right? A newton is a meter, kilogram, meter per second squared divided by kilograms, right? They are the same thing. And then the second reason I'm doing that is that when we talk about field strengths, we talk about newtons of force per unit of whatever it's acting on. So for gravity, gravity acts on kilograms, right? Does that make sense? So you can say it that way. So if I have 2 kilograms, I've got 19.6 newtons of force. If I've got 1, I've got 9.8 newtons of force, right? You can make a little triangle like this, right? Weight is m times g. Here we have it, right? Just like F equals ma, right? You don't really need a new formula, but there it is, right? Okay. So, for example, if I have 3 kilograms, okay, what does it weigh? Don't say 3 kilograms, right? 3 kilograms weighs 3 times 9.8. What is that? 29 point, what is it? 29.4, is that what it is? Better check that. Is it 29.4? We don't want someone. There we go. So that's simple. So this is its weight. This is its mass. What if there's no gravity? What if that's a zero? What if the gravitational field is zero? We still have mass, but mass times zero is zero weight. Yeah? It's a fairly simple concept. Okay? Yay. So here's some astronaut, right? This is, I don't know if they're fixing the space shuttle or something like that, or they're fixing the Hubble telescope, but this thing here could, if on Earth, might weigh 500 pounds, right? Yeah? Okay, but in space, of course, it has no weight. It still has all that inertia, so it's hard to get it going, and it's hard to stop it from moving, right? But presumably this person has, they're either on the end of the crane, right? Like, so the space shuttle's got the little crane that sticks out there, and they're attached to it, and the crane is moving them, right? or they've got like a thruster pack on and they can right, and move themselves around. But you don't need a crane in space. That's kind of interesting, isn't it? Right, just enough astronauts with little jetpack thrusters can move the stuff around, and then you can bolt it together or weld it.
How would you move a heavy object? Without like a crane or something to hold
You need like a jetpack or something. The question is how you move a heavy object.
Yeah, without
You need like a jetpack, a super duper jetpack, and just keep pushing on it.
physically impossible without it. I mean, you're basically pushing yourself.
Yeah, if you're just floating there in space and you pushed it, what are you going to push off of, right? If it's got more mass than you and you push it away from you, you'll go flying, right? But yeah. Alex, don't do that. Thanks. So let's get out the whiteboards and try this. So this is the mass versus weight PowerPoint, and we're just going to do these whiteboards. I'm going to sign off here.